Hi dear students and viewers, welcome back to our channel N Kumar Basics of Physics. Dear students, in this video we are going to discuss about the one activity that should be explains the relation between the resistance and length of a conductor. Clear? What is the relation between resistance and length of the conductor? We are going to prove with one activity. That's important one. So children, if you want to understand the complete topic, you have to watch the video up to last without any skip. So dear students, we have the relation is there between the resistance of the conductor is, that is directly proportional. Simply resistance of a conductor is directly proportional to the length of the conductor. So the resistance is directly proportional to the length of the conductor. We can write like this: R is proportional to L. When length of the conductor is increases, resistance also increases. When the length is small, resistance also small. So children, in formula problems we can use this formula: R1 by R2 is equals to L1 by L2. R1 by R2 is equals to L1 by L2. So children, here we have to discuss about already R is proportional to L by A and R is equals to rho into L by A. Here what is L? Length of the conductor. What is A? Area of cross section. Resistance of the conductor is directly proportional to the length and inversely proportional to area of cross section of the material. So here rho is called specific resistance. What is rho? Specific resistance. So to explain the relation between the R and L, we have to maintain rho and A are constant. So to explain the relation between R and L, we have to do one experiment. In that we have to maintain A and rho. Both are seems to be constant. So to maintain the rho is constant, we have to use the same type of wires. That means they made by one material. That means what? If you can take copper wire, next wire also belongs to same copper wire. So when we are using the same particular type of material, then resistivity is same. So to maintain the rho constant, we have to use the same type of wires. And when we are using the different type of lengths, then area of cross section should be maintained constant. That is you have to maintain two steps. First one is what? In this activity, if you want to prove the relation between the resistance and length, simply how to maintain the rho and A should be constant. How we can maintain the rho is constant? By using the same type of material. Either you can use copper, or you can use silver, or anything water maybe. You can take only one type of material. So children, now let's go for experimental procedure. First we have to take the one battery. Clear? From that we have to give one ammeter, and from that we can give to the one plug key. And from the positive of the battery we are given to one wire, and from this also we have to give one wire. So this is the experimental arrangement. Now it is the open circuit. In open circuit there is no current. So here this is what children, this is the battery that will create the potential difference. And what is a ammeter? Why we can use the ammeter? To measure the current. And this is the key. What it is? Plug key, like switch. Okay. And these are the wires. Now here P and it is Q. In between these two we have to give one conductor. Okay. Now we have to take the a wires, different wires having different lengths. For example, this is the 20 centimeters, 30, 40 and 50 centimeters like that. But what you have to maintain same, all wires are having same area of cross section. And next thing is what all are having? Yes, all are made up of same material. Now I am saying copper, I am saying now it is copper. Clear? We are taking some copper wires. Now here in our tabular form, in our notebook you have to maintain one tabular form like serial number and length of the wire and current in the ammeter. Clear? So simply what we have relation R is proportional to L we have to prove. So let us check where it is right or wrong. Clear? First thing is here when we are taking a length of 50 centimeters. A copper wire of length 50 centimeter is connected in between these two. Then you can close the plug key and you have to check how much current we are getting in the ammeter. So first thing here 50 centimeters. So children, what we know, V is equals to IR. Here we are using the same battery, means that is what potential is same. And I is proportional to 1 by R here. When resistance is more, current is less. So here we are reading some here now 0.2 amperes. When we are using the 50 centimeters in between these two, we are reading 0.2 ammeters. Clear? Amperes in the ammeter. Next after that we are taken, it is replaced by the 40 centimeters wire. So that means what? Length is decreases. So now we are reading some 0.3 amperes. Now it is replaced by some 30 centimeters wire, copper wire now. Then again you have to check how much current is shown in the ammeter. And next again same thing by 20 centimeters. We are reading now 0.7 amperes. So just we are reading the readings like this. For 50 centimeters volt is 0.2 amperes. For 40 0.3, 30 0.5, 20 0.7 like that. So when length is more, we are reading less current. So when length is more, then the current is less. Why? Because the more length wire has more resistance. When length is more, the resistance of the wire or conductor is also more. When resistance is more, current is less. Got it, children? When length is more, resistance is more. When resistance is more, current is less. Clear? That's why here now, when length is less, then resistance also less, also low. When resistance is low, current is more. That's why for 20 centimeters length we are reading the 0.7 amperes. For 50 we have only 0.2 amperes. That means when length increases, resistance also increases, then current is decreases. So from this activity what you put, children? Resistance of the conductor is directly proportional to its length. When length increases, its resistance also increases. So very simple activity. If you can understand this one, children, like, share, comment the video and subscribe our channel to your friends also. Okay, thank you for watching.